We know that every action has an equal opposite reaction, so in order to get our ball bearing to the top, we added an equal and opposite force of poker chips in the other cup to act as a pulley. Our ball bearing then went down a funnel and followed onto the pipe insulation. The tall height of the first drop gives enough gravitational potential energy to be converted into kinetic energy to make it around the loop and up a second hill and around a curve.
Here are some examples of how we found calculations for the top of the loop. To find height, we used a measuring tape to find the height of 14.28 inches. We then converted it to meters, which is 0.36 meters.
We found velocity by setting the GPE at the start of the first hill equal to the GPE and KE at the top of the loop. We found the height of the loop by using measuring tape and converting it to meters, which resulted in us finding the height to be 1.53 meters. Next, we plugged in the diameter of the loop that we found by measuring, which was 0.36 meters times gravity. We took this plus kinetic energy, which we plugged in our 0.02 for mass, which we found by weighing the ball bearing, and left v as our variable for velocity. We then solved the equation.
We found our energy using the potential energy and kinetic energy formulas. At the top of the hill, you have potential and kinetic energy. We did 0.02 times 9.8 times 0.36 for the potential energy formula, which equaled 0.071. 0.02 came from the mass of the ball, 9.8 is gravity, and 0.36 is the height. We then used the kinetic energy formula and did 1/2 times 0.02 times 2.4 squared, which equaled 0.229. We then added the two energies to make sure they added up to 0.31, which is our total energy, which they did.
We took our velocity, which was 4.8 squared, divided by the radius, which was 0.18 meters. We found the centripetal acceleration at the top of the loop to be 128 meters per second squared. This is too fast of an acceleration, it exceeds 4 Gs. Our people would most likely be dead.
We found the work from doing the change in energy, which was 0.31 joules. For our centripetal force, we are using an example that came from the bottom of the loop. The equation we used was velocity squared divided by the radius and multiplied by the weight. With numbers, our equation was 0.196 kilograms times 0.55 meters per second squared divided by 0.18 meters. This equaled to be 0.33 newtons. The 0.196 was the weight of the ball. 0.55 meters per second squared was the velocity, and the 0.18 was the radius. The energy dispersed to bring the coaster to rest was negative 0.31 joules, because in order for it to stop, you need to take away all of the total energy.